Let's solve theta in this trig problem. What we have here are two right angle triangles, and looks like we don't have enough information to solve this angle here. So what we're going to do is we're going to find this length here. We'll just call this C, and we can use the Pythagorean Theorem to solve length C. We'll say that C squared equals some side squared here plus the other side squared. And you can work it out. C is going to be approximately equals to 26 meters. Now, another thing to notice here is that this special triangle here is in this shape, and it happens to be very similar to the 5, 12, 13 triangle. So it's good to memorize certain triangles. We have a 3, 4, 5 triangle, and the 5, 12, 13 is another good one to memorize. And what we have here is the 10 is double 5. So in the same way, 24 is double 12. And so C should be double 13, which is 26. So that would be the faster way, rather than computing using the Pythagorean Theorem. So what we have here is C is 26 meters. And we know SOHCAHTOA, this is trig. We learned SOHCAHTOA is a nice way to memorize that sine of some angle equals opposite over hypotenuse versus cosine is equals to adjacent over hypotenuse, and tan of an angle is equals to the opposite over adjacent. So what we have is you just put your finger here on this angle and you think about what we have. We have the opposite and we have the adjacent. This is not the adjacent because this is the longest side, which is opposite the right angle. This is the hypotenuse. But what we have here is putting your finger here, we have the opposite and the adjacent. We have the opposite and the adjacent. We're going to use tan. So what we say is tan of some angle, this is trig, is equals to the opposite over the adjacent. So the tan of some angle is equals to the opposite, which is 20, over the adjacent, which is 26. So this is not the answer yet. That's not theta. That's tan of theta. How do we find theta itself? What we do is we eliminate this trig function by using the inverse. We take the tan inverse of both sides. So the tan inverse of tan theta is equals to the tan inverse of 20 over 26. So the inverse trig function, as long as these are the same, they cancel out, leaving the angle theta exposed. So again, theta is equals to tan inverse of 20 over 26. And making sure that your calculator is in degree mode, we compute this as theta is approximately equals to 37.6 degrees. And visually, when I look at this picture, that seems pretty reasonable. So the key for this problem is to make sure that you put your finger here on the angle and you work towards using the SOHCAHTOA. Write this out because it's very easy to commonly choose the wrong trig ratio here. Make sure that your calculator is in degree mode, and just be careful about crunching out the correct C value as you use the Pythagorean Theorem.